at section 1.2, page 1 of the notes. We're going to do some fraction review because throughout 60 and 65 you're going to need to be comfortable using fractions with our algebra. First we'll start with just fractions with variables, and then we'll move on to fractions that have variables in them. But for this section we're just going to be reviewing what we need to do with fractions. And the first thing is to convert each mixed number, mixed meaning there's a whole number and a fraction, 6 and 2/5, 2 and 7/9. The 6 and 2 are whole numbers, the 2/5, the 7/9 are the fractional part of the mixed number. So a mixed is a whole plus a fraction. Okay, and we're going to convert that to an improper fraction. Improper is such a horrible name, I think, for it because it makes you think like it's a bad thing. It's really not a bad thing. It just doesn't feel like we're used to. We're used to a fraction being a part of something, and an improper has like a top heavy. It has a numerator that's bigger than the denominator. So a bigger numerator than the denominator, and that's what makes it improper, meaning the denominator goes into the numerator more than once. You have a whole piece and a fraction being represented in one. So there's more than one whole in that fraction. So it's not a bad thing, it's just it's not a fraction in the sense of what we're used to, it being a part of a whole. But we're going to be it's going to be come in very handy for us, very useful in Math 60 to have an improper fraction, especially as we get towards, again, our big payoff, Chapter 4, lines and graphing linear equations. Having it in fraction form, whether it's proper or improper, is going to be very useful. Okay. All that to say, because I don't want to ramble on here, let's work at converting each mixed number to an improper fraction. Hopefully this is review for you. If any part of section 1.2 dealing with fractions is difficult, get help right away. Come see me, set up some time to go to the Student Learning Center or the Multicultural Center, wherever the free tutoring is available for you, or if you have a good help resource outside of that. But don't go any further until you get really solid in your fractions and you understand what's going on. I know it can be a real stumbling block for people, and we use them a lot in Math 60 and 65, so get the help that you need. When you convert a mixed number, the steps that you want to take, it's kind of I like to think of it as kind of a traveling path here. From the 5 to the 6, we're going to multiply. And then we'll move from that result up to the 2, and we're going to add that. Okay, and the denominator stays the same. So in this case, we're going to have a 5 times the 6 plus the 2. That gives us 30 plus 2, using order of operations, or just 32. And then that 32 stays over that same denominator of 5. So 6 and 2/5 is really 32/5, and that's how you would say that. Now, why does that occur? Well, one thing I try to emphasize is why things happen. There's two reasons for that. One, if you get stuck in an exam situation, sometimes you can't force yourself to remember the rules, but if you understand why math works the way it does, you can recreate it for yourself and come up with how to do the problem even if you've blanked on the actual rule. The second reason, though, is because what works with numbers also works with the variables, with the algebra. So if you can understand why things are happening with the numbers, you'll be able to then apply it more easily to the variables when the numbers aren't visible and you're dealing with letters instead of numbers, which is what our focus is in 60 and 65. It's the algebra part of it. So, so why is 6 and 2/5 equal to 32/5? Well, 6 represents a whole number, as if 1 was being added to itself 6 times. And each of those ones can be represented as 5 out of 5. If the whole pie was cut into 5 pieces, 5 of them would make one whole pie. So imagine 5 over 5 being added to itself 6 times. That represents the 6 part of the whole number. 1, 2, 3, 4, 5, 6. And then you add that additional 2/5 that's sitting there. 6 and 2/5 is what we originally had. Well, you have a like denominator all the way across, and so you keep that denominator of 5, and you add up 5 plus 5 plus 5 plus 5 plus 5. There's 6 of them. 6 5s is 30. Add the additional 2, there's your 32. So that's why the rules aren't just made up. There's no committee who decides it. It's a shortcut based on a pattern that we notice happening with the numbers. Then we'll be able to apply that shortcut as a rule when we don't know the numbers, when it's just variables and algebras involved. So applying that now, take a moment to copy this, tell somebody what you've seen, note any questions you might have, and then go ahead and try number 2 here. And I'll give you a chance to pause the video, then we'll reveal the answer. Okay, hopefully you've had a chance to pause, because here comes the answer to number 2 as a mixed number. That should be 25 over 9. And again, I'm highlighting some things in the book that should be helpful for you. On page 15 is the book's reminder for how to convert a mixed number to an improper fraction. I try to describe it the way it makes sense to me. The book is written by a human author, obviously, and he has his way that makes the most sense to him. And again, it uses very formal mathematical vocabulary. So between the two of us, myself, the book, maybe even have some other outside resources, there should be lots of ways that you can listen and hear about and think about these different types of problems. One of the things I wanted to note is if you're struggling with fractions, one of the ways I use to remember is the difference between denominator and numerator. Denominator starts with D. D is for down, and that represents the bottom number of the fraction. So that's what I use. And one of the things we'll also talk about Math 60 is the types of numbers that are out there. And this is the first reference that we have, and that is natural numbers. When he talks in his definition, those are the counting numbers. One, 2, 3, 4, 5, etc. Those are what the natural numbers. His description here is multiply the denominator of the fraction by the natural number, meaning the number in front of the fraction here, the whole number, the how many whole pies we're talking about, or cookies, or fraction bars, or however you learned fractions. And then you add the numerator to this this product. Sorry. Okay, so and then place the result from step 1 over the denominator of the original mixed number. So again, just a very verbal description of what you need to do. However it makes sense to you. I'm not going to ask you to repeat the steps on a test or anything, but you should be able to talk it through and explain it for yourself or to somebody else, and that will really help make it stick as you're trying to remember how to do these. Okay, that takes care of the top of the page. We'll see you at the bottom of page 1.